So we are going to start chapter 4 here with 4.1, and this is on page 151, and we're going to look at relational operators. And for those of you who I know I've been saying this, that we are not really going to deal with tremendous math. This is all going to be lower level type math. So please do not let the PTSD of your previous 12 years or more in school get the best of you here. We really, truly are dealing with just very simple shades of math here. And what the relational operators allow us to do is to compare the value of two either numeric values or two character values. So before we get too far into it, here it is on page 151, and I'll just scroll this down a little bit so we can see it a little bit better. It's table 4-1, and it's still page 152. We have 2, 4, 6 relational operators here that we are going to use. So we have, and these, again, these are not aimed at triggering your math anxieties. These are really, truly very simple cardinal concepts to the way it is that we think about how we use math. Just in a more general sense outside of the developer's environment. So we do have greater than when we compare two numeric values, let's say two integers, 2 and 4, is 4 greater than 2. Yes, fantastic. In that case, the greater than would evaluate as true. Is 4 less than 2? So less than is our second relational operator here. No, that would be false, right? Because 2 is in fact less than 4, unless we're talking about 4 in 2000, in which case we weren't being honest about the math that we put there in the first place. Now, something that developing developers do occasionally miss is the idea that we can see here of less than or equal to or greater than or equal to. So the example that I usually say is, okay, you've got a bank account, and let's say you have an even $100 in there to withdraw. And what happens if you withdraw $100 and you have a balance of 0? This is where, developing developers and experienced developers oftentimes will make a logic error. So let's say an overdraft fee is initiated when you go below that $0 threshold. So what we want is less than 0, right? So that means if I am in the negative, I will initiate an overdraft fee. So when I have negative 1 cent as my account balance, boom, overdraft fee. So that would be less than 0. But less than or equal to 0 would suggest that at $0, I would initiate an overdraft fee. Now, I'm not here to tell you banks operate fairly. That would be silly of me. But, that's a rule that we could say. We could do it with, the grade point averages or the points averages rather that we would have for your GPA. So typically speaking, here at Rock Valley, if you have a 90 or greater, you have an A. If you have an 80 to an 89, you have a B, and so on and so forth. So if we say greater than 90 equals an A, what happens when you score 90% on something, or when you get a 90% as your average for an entire course? Well, because we said greater than 90, you get a B, because at 90, that's not the way the logic works for that. So if we're saying that 90 and above is an A for Rock Valley College, then we would have to say greater than or equal to 90 in order to account for that number 90 there. This is where students, you'll see this pop up in some of your first end of chapter exercises in the chapter here for 4. And I do have you do a couple of these in another couple of weeks for the chapter 4 challenge problems. There is a logical difference between greater than, and there's a logical difference between that and greater than and equal to. So it's something that you have to be aware of. So coming back down here to our table 4-1 on 152, we also have the idea of is equals to. So in that case, we have the two equals. And let me suggest to you that this is important. It's something that a developing developer is going to forget to do. And the results can be difficult for you to go through and determine why your logic isn't working here. If I just have a single equals, so 4 equals 4, what the system sees is an assignment is happening. So what it's going to attempt to do is say, okay, can I assign the value on the left-hand side, or assign the value on the right-hand side of the operand to the object on the left? And that's not what you want to do. You want to check if the object or the number on the left-hand side has the same value as the object or the number on the right-hand side. So it's equals equals when we are looking to compare. It is the single equals when we are looking to assign. Now, there's examples of this at the end of the chapter. So you're going to see this, and a fair percentage of you, honestly, are going to step in this, and that's okay because you've only seen equals as giving something a value, and here we are adding the added layer of complexity of comparing with the equals. And while we're talking about complexity, we have the idea of not equal to. It's the bottom one here on our table 4-1. So we are making sure that two values are not the same. This is an exclusive number. So if I have two doubles and I have 5.0001, and on the other side I have 5.001, I have 100th of difference between those, or 1,000th rather of difference between those, and those are not the same. So not equals to would evaluate as true, right? Because 5.001 and 5.001 are not the same. So this one is kind of logically, I'll call it negative of the other ways that we're thinking of things, because every other example we've used here, table 4-1 on 152, we are looking at things to be true. This evaluates as false for something to go through, not equal to. So it's a little bit different in the way you might think of things, but it does work out to be logically in your favor to be able to say not equals to things, because it's a really quick way to eliminate whole big portions of logic. It's like, what do we have to test? You can eliminate a lot of things with that not equals to relational operator. So we've got these 6 things. It doesn't look like much, but from small tables come mighty outputs. And we are going to be able to do a ton of really valuable decision making with just this set of relational operators.